My talk is actually very simple. I put it in a very simple language, so you will all be able to understand that. So my talk is about the weather satellites, and all this satellite needs actually start with the weather. So nowadays, actually, the importance of weather, everybody understands, everybody knows. No activity of our society can be completed without the information of the weather. Weather forecasting plays a very major role in many places. For example, I start with the aviation. Actually, aviation, like the flights, etc., they depend a lot on the weather forecasting support, and it cannot move without the weather forecasting, because the taking off and the landing of the aircrafts critically depends upon the weather situations. And sometimes it becomes normally it does not create a problem, but when it creates the problem, it becomes a big problem for aircraft industry. So weather information, how the weather is going to move, is very important. It is very important for the agriculture, actually. So all the food production, they critically depend upon that how the temperature will vary, what will be the maximum temperature, what will be the minimum temperature, because the agriculture is one industry where all their assets are exposed under the sky. So anytime one big event can spoil everything. And not only that, that is one extreme event I'm talking. The crop growth, how much will be the yield, it depends a lot upon how much will be the rain and how much will be the temperature variations. So all these things the farmers community need to know, and there is a big impact actually. I think if they know the weather very properly and very precisely, they can increase their profits by around 20%, which is quite a big amount. Then similarly, you can see that the tourism industry, sports industry, even the shopping malls depend a lot. For example, the monsoon season is starting in India. So the mall people want to know that what kind of rain it will be. Will it rain very heavily? So they will stock the rainy items like the umbrellas and the raincoats, etc. And it costs a lot, because they have to make inventory of all these articles, and they have to store those items into their stores. And if it does not rain, then all this exercise goes waste. So they have to know very clearly that what kind of weather it is going to be, so that what kind of demand will be there in the market for different kind of communities, different kind of commodities. So this makes a lot of business sense, and they can make a lot of profit, or they can make a lot of loss with or without the proper information of weather. Similarly, you know that there are some extreme weathers like tropical cyclones and the flash floods, even droughts. People can do advanced planning if they know that what kind of weather they are going to face. So there are a number of things. Even we are from the ISRO community, which is basically, it has a very big presence in the launch market. And for the rocket launches, the weather plays a very important role. For example, there are a number of operations. For example, when you fill the fuel into the rockets, it is a cold, very cold cryogenic fuel. It is a minus 200, minus 250 degrees centigrade temperature. So a small amount of like a lightning can spoil this whole thing, all the filling operations. Similarly, when the vehicles move from their spot to the launch pad, so even a small amount of wind can create a lot of problem. While at the time of launching, the convective weather, like the very cloudy weather, lightning, etc., they can spoil the whole launch exercise. So this is very important. Then nowadays people are very much bothered about the air quality. Then the heat waves is becoming a big problem nowadays. The heat waves, and some of the states of India, and particularly I think in Africa and other places like Oman and Asia, other regions of the Asia, I think heat wave is becoming a big problem these days, and it is a big health problem, because then people they're exposed to the heat, and then there are a lot of health issues, particularly to the elderly people. This heat wave and heat strokes are becoming a big problem these days, and scientists have predicted that these kind of events may increase in the future. So all these things has to be advanced warning. And then nowadays there are a lot of stress on the solar energy, wind energy, and crop forecasting. So for all these things, weather forecasting is becoming more and more important. So now And another thing is the hydrometeorological hazards like the floods, tropical cyclone, droughts, heat wave. I have already talked about that. They are very expensive. If you see the scale of how much they cost to the countries, like the floods cost around $400 billion worldwide. And then cyclones cost around $200 billion. And droughts cost $34 billion. $3 billion is the cost of heat waves, the total loss incurred by due to that. So weather forecasting actually makes a lot of economic sense also. So if you can predict the weather properly, we cannot prevent all the losses, but I think around 20% losses can be prevented if with the proper warning and the proper predictions. And you can see that the tropical cyclone is one big problem. Not problem, actually this is a sign of the climate change. And particularly the people who are living in the Oman, they may be knowing that the tropical cyclones are reaching up to Oman nowadays also. So in 20 years back, the tropical cyclones were not reaching up to Oman. So they were, but nowadays at least one cyclone regularly comes to the Oman coast. And the Arabian Sea is very active these days. So in the last 10 years, we are seeing that the Arabian Sea activities are increasing a lot. And this is also a sign of the climate change. And we have to not only predict, we have to also understand that why these tropical cyclones are increasing, what is happening to the climate change, and what will happen if these tropical cyclones increase in the future. So, for example, this is one of the examples of the tropical cyclones, and this is one of the very unprecedented kind of tropical cyclone that hit the Gujarat coast where I live, and there was a widespread damage by this tropical cyclone, and people have studied that these tropical cyclones are increasing in the intensity, and this tropical cyclone had an impact up to 2,000 kilometers. So it went all the way from the west coast of India and then all the way up to Himalayas. So even in the Himalayas, people experience a lot of rainfall due to this tropical weather system. So these kind of systems are becoming more and more prominent and more frequent these days, and which makes the study of these events and the observation of these events very critical matter. Similarly, the floods. Nowadays, you know that the flood is #1 hazard, meteorological hazard, because tropical cyclones, you know the tropical cyclone is coming. You know 5 days in advance that the tropical cyclone is coming to Oman or tropical cyclone is coming to India. We know very well. And nowadays, the weather forecasting has improved so much that we know 5 days in advance that exactly where it's going to hit. So people make advanced preparations, and nowadays people don't die because of the tropical cyclones much. There is a lot of property damage, but personal loss of life has been minimized because of the tropical cyclones, because we know that tropical cyclones very well. The flash floods is one thing that is still, the prediction of flash floods is still not very accurate because they come very suddenly. In the morning, you don't know that in the daytime a flood is going to come. So they develop very suddenly, and then they create a lot of havoc, and then after that they leave a trail of destruction behind that. So nowadays, these floods have become a #1 calamity, meteorological calamity, and it is a challenge to predict these floods and this kind of heavy rainfall events, sudden rainfall events, very precisely. And this is one of the challenges. So how actually we do all these things, and how the prediction business actually comes into picture, and how we are able to predict it. So basically, every scientific study basically starts with good observation. So there are 3 processes, as you are teachers and you all know very well, that we basically there are 3 processes. Basically, first we have to observe some certain things, then we have to understand it. First we observe, then we understand, and then based on that understanding, we make. So you want me to reply these questions, Dr. Harish?
No, sir. Not live. Okay, just something.
Okay.
You please.
Okay.
Okay.
So at the end of the lecture. Yes, we'll do that. So first we observe, then we understand, and then we predict the predict the weather. Everything, not only weather, everything in the science, like even in the chemical reactions, we are able to predict because we understand about that. How we understand? Because we have observed this phenomena very clearly. So first thing is the observation. So the first thing in this thing is the correct observations. Everything starts with observation, a good observation. So that is what is my today's talk is totally devoted. So how we observe the weather? So the first thing in the first most basic thing in the weather observation is basically the conventional surface meteorological observations, observatories. This is a very simple instrument. You can see that there are the winds. There is some wind vane, that is wind is blowing, and there are some instruments. You can see this. This instrument is basically, this instrument measures the temperature. Then some instrument measures the radiation. Some instrument measures the rainfall. This is the rain. This is the small rain gauge instrument, and all these instruments is small weather observatories. And this is the very simplest of the weather observing system. And this is not only, it is only simple, but it is very important part of the entire weather observation system. So how much these observations are? Basically, these observations are approximately 10,000 such observatories are there, which are managed by the governments. And you can see the big problem is there. You can see the parts of the Africa where we are having a lot of African deserts. So these deserts are, and a lot of parts of the Himalayas and deserts and some parts of the South America and lots of parts of the ocean. It is not covered by this kind of instruments because it is very difficult to, they are basically manually they have to be done, and we are not able to keep them manually. They have to be, not only they have to be kept there, they have to be maintained also. Their battery has to be replaced, their instrument has to be monitored all the time. So it is not easy to do. For example, in the Greenland, you can see there is, inside the Greenland there is only one observatory. In the Canada there are very few. In the Africa there are very few. In India, but in the Europe and in America, you can see a big density of all those things. Even in the desert part of the Australia, you see that even though Australia is quite a good developed country, rich country, but you can see that there are not many such observatories inside the Australia. So I want to say that it is difficult to maintain this kind of manual observatories. And they are only 10,000. But nowadays, lots of people are coming. There is a lot of interest in the weather forecasting. So a lot of private people have come up with their own observatories. They are very cheap instruments. They are available in less than $300. You can buy this kind of instrument in less than $300. So lots of private people are buying this kind of things, and you can see in the Europe and in the America and parts of the South Africa, Australia, people in Japan, people have several private people have bought this kind of weather station, and private weather stations are much more than the government weather stations. They are approximately 250,000. It is, I think, 25 times bigger infrastructure than the government ones, and they are quite good maintained. And but this data is not available to everybody, so that is one problem. Now the problem is that the weather is not limited to the only surface. The weather is three-dimensional. So we are having the weather in the upper air also. Even though we don't bother much about what is happening at 10-kilometer height or what is happening at the 2-kilometer height, we are mostly worried what is happening at the surface because we live in the surface. But actually, what is happening at 10-kilometer height or 6-kilometer height, it affects our surface weather also. So it is very important to know what is happening at the upper air, what is happening in the three-dimensional weather, three-dimensional atmosphere. So for that, there are different kind of instruments, what is called the weather balloons, and they are controlled by the GPS. They are fitted with the GPS, so we know exactly how, where they are moving. So they are actually launched every. Some centers launch it 2 times a day. Some centers launch it 1 time a day. But there are approximately 1,000 such stations, and they give us very important information about the upper air weather. So what is happening at the 1 kilometer or 2 kilometer or 3 kilometers? So this I have shown in this kind of a three-dimensional layer. So in the lower part we are having a very hot temperature, but as you go up, it is very cold temperature, and this difference actually creates a lot of weather. So when it is a lot of warming and lot of wet weather, a lot of humidity in the surface, and then we are having very cold weather in the top, then this is an indicator of the very convective weather, like thunderstorms and very big kind of heavy floods kind of situation is occurring. So it is very important to know what is the weather and what is the how is the weather in the upper atmosphere. It is very important observation. So you know that similar to the surface observations, we are having approximately 1,000 upper air observations, and not many private players are in this business. So these are mostly maintained by the government agencies, and 1,000 you can see again there are a lot of gaps even in India and a lot of part of Canada, Africa, etc. So we are not having many surface observations. They are mostly confined to the land and some island stations and some ships also. So yes, whatever you are seeing in the ocean, it is basically they are launched from the ship. So there are 1,000. So you can see this by seeing this picture that it is not enough. These observations are not enough to fill the entire Earth, because we cannot ignore what is happening over the ocean, because ultimately the ocean weather is coming to land, and then it is creating the weather in our city. So we have to know that what is happening at the oceans also. So for that, actually one of the very important observations I forgot to mention, it is coming from the aircrafts. So all the commercial aircrafts are actually fitted with the weather measurement instruments. So when an aircraft is taking off, so it is every 1 second or every 2 seconds it is measuring those observations. It is measuring the temperature, it is measuring the wind, pressure, humidity, etc. And it is one of the most variable observations actually, because the aircraft is physically measuring them. It is actually measuring them. So we are it is not that something we are doing by the remote sensing. It is actually aircraft is taking off, and all the upper air observations it is taking. So this is one of the very accurate and one of the very valuable observation. But you can see that because of the COVID situation and the lockdown situation, and international flights are not going up. So you can see that what is the situation? What was the situation in 2020, in 2019, and what is the situation in 2020? So there is a lot of difference in this observation. These observations are not getting available nowadays because flights have they have reduced their operations, and this data was going into the weather forecasting models. So this kind of lockdown situation has also affected the weather forecasting accuracies also, because this data is not going. So weather forecasting models are not knowing what is happening at the upper air. They are not knowing good enough. So it is also affecting the forecasting capabilities. So this I want to show to tell you that how these observations are very important for making the predictions also. Similarly, we are also having a lot of oceans are covered, but they are giving us the oceanic observations like the sea surface temperature, the deep ocean temperatures, the deep ocean pressure, deep ocean salinity. Mostly they are not giving the atmospheric observations. They are the oceanic buoys, and they are mostly focused on taking the oceanic measurements. But it is nonetheless a very important observation. So basically, by the previous examples, it is clear that now we need some observation. We can cover the entire Earth, including the oceans, and which can give us the day and night surveys, and we can get the total observations all the time under all the conditions. So what kind of observation instrument this can be? So only one thing comes to our mind, that is satellite. The satellite is the only instrument that can give you global coverage by single instrument. So that is why satellites have become a very important necessary part of the weather forecasting services. So what is the advantage of satellite observation? The number one advantage is the coverage. The satellites can give you the amount of coverage that one ground-based instrument can never give. Similarly, the satellites can give you the repeativity. So it can give you you can see in the second diagram that some satellite is repeatedly giving the observation. So for example, nowadays weather satellites can give you the weather observation at every 10-minute interval, every 15-minute interval. So this is unprecedented. Every 15 minutes you can update what is happening in our surroundings and what is happening in our area. So this is very important to monitor the weather. If there is a thunderstorm is developing some 100 kilometers from my city, so if I can monitor it every 10 minutes or every 15 minutes, we can very quickly know that how fast it is moving towards our city, and very advanced warning can be given. And lots of measures can be taken, like the traffic can be stopped, or maybe the people can be told to evacuate. The schools can be told to shut down, and then the children can be taken to the safety. So this is very important to do the nowcasting and the forecasting of the weather. And the third important advantage is the representativeness. What is representative observation means? As I showed you in the previous pictures, that there are thousands of instruments which have been installed by different government offices, But each instrument is separate. So if one instrument goes wrong, we never know that this instrument has gone wrong and this is giving wrong observations. But in the satellite, what happens that this is one instrument which is measuring everything. In one satellite, this is one instrument that is measuring the entire Earth. So if something is wrong, then we have to correct that instrument only. Then all the observations will be corrected automatically. So that is called the representative observation. It means all the observations are taken by one single instrument. That is a big advantage. So, because of that, historically, in 1960, April 1, the first weather satellite was launched, and that is called the TIROS-1. So basically, it was the television infrared operational satellite. So it gave us the pictures only. It did not give us any digital data. It was not a digital picture. So nowadays, even a mobile camera has a digital pictures, but this satellite, it was quite a big satellite, but it gave us only the analog pictures, not the data, only pictures. But those pictures were very valuable because those pictures told us that weather is not confined to one country. Weather is universal. Actually, it is global. So what weather is coming to India, basically it comes from other countries. It comes from Bangladesh, it comes from Pakistan, it comes from Russia. So without understanding the weather of Russia or weather of Pakistan, I cannot predict the weather of India. So the weather of India cannot be predicted by observation taken over India, or weather of Oman cannot be predicted by if you take only observations from Oman. So you need some platform where you can take the global observations, and that is for that the satellites are the most important tool and most important observation. And since that time in 1960, these observations have gradually improved over the time, and they have become more and more sophisticated. So initially we had only the TIROS analog pictures. Now, then there was a time in 1970s, by 70s, people were working on the digital type of pictures where they can analyze those pictures, they can use those pictures in their mathematical models. Then slowly, initially people were working with the infrared visible kind of things only. Then they slowly went to the microwave frequencies. Then they went to the active radar. They installed radars in the satellite systems. So nowadays satellites are having many radars on their their instrument list. So they provided us lots of other observations like the ocean surface winds, etc., and the precipitation profiles. Then they went to the hyperspectral. So hyperspectral means nowadays the satellites are having thousands of channels. They are having pictures taken in thousands of bands. So when they take a picture, there are at least 8,000 pictures they are taking at the same time. So with this kind of hyperspectral imaging, what happens that they are able to tell a lot of things about the weather and the clouds. So, and then I'll cover these things in my subsequent slides. And recently, in 2020 or 2019, there is a very powerful laser has been put in the orbit, and which is measuring the movements of the aerosols and the molecules of the air, and indirectly or directly it is measuring the winds, how much wind is blowing in the atmosphere. So this is how much wind is blowing and at what level it is blowing. So that is the latest development that is in the atmospheric sciences, in the meteorological satellites. It is a very powerful laser we are having nowadays, and it is giving us the very variable observations of the vertical structure of the wind. So these are the instrument. This picture shows that how the satellite instruments have progressed over the period of time, and it is lots of new things are happening, some of which I will try to cover in my slides. So basically, how the satellites take the observation. This is one of the most popular orbits of the satellites. So you know the satellites, once you launch a satellite, the satellite will go into some orbit. So orbit means how it rotates around the Earth. So it can rotate from this to this side also. This is called the polar orbiting satellite. But this satellite is having a very special significance. What is the relevance of this orbit is that it rotates with the same speed this rotates with the same orbital speed as the Earth. So what is the advantage of that? When the satellite rotates like this, then the Earth looks stationary to that. So that's why these orbits are called geostationary orbits. So geostationary means with respect to this satellite, the Earth looks stationary. So what is the advantage of that? So this particular satellite is the example. In this example, the satellite is situated over the south is the America. So for the American persons, this satellite is stationary, and for this satellite, all this whole part of this America is stationary. So it means whatever is weather is taking place over there, whatever clouds are moving, it does not matter that whether Earth is moving or not, because it tracks only the movement of clouds. It does not track the movement of the Earth. So that is the big advantage. So Earth looks very stationary with respect to this kind of satellite orbits. Now, there is one big disadvantage of this orbit is that this is in the equatorial plane. So some angles become very unfavorable. So some high latitudes like Russia and South Africa, etc., they are not very clearly visible with this kind of angle. So it can see only the plus minus 50 from any part. So this is the inside 3D, for example. It can look only plus 50 degree and minus 50 degree. So it can look only a small part of the Earth. It cannot look entire Earth because the upper part becomes very, very blurred, and the resolution of and the clarity of those pixels are not very good. So for that, there is some other orbits people have thought of, like the polar orbits. So what polar orbit does is it goes pole to pole. So when it goes pole to pole, it takes the measurement from a very nearby surface, very near to the Earth. It is this kind of satellites are hardly 800 kilometers from the Earth, while the geostationary satellites are 36,000 kilometers from the Earth. So in this, what happens? This satellite is going from pole to pole. In the same time, the Earth is moving from west to east. So satellite goes. So when satellite comes next time, satellite sees in a different part of the Earth. So as a result, in one day, the satellite scans the entire Earth. But the disadvantage is that at one time it sees only one small part of the Earth actually. But in one day it sees the entire part of the entire Earth, while the geostationary satellites will look at only one face of the Earth. So that is one disadvantage and advantage of these two different orbits. Now, what happens that because of the geostationary kind of things, the upper latitude, the people living in the upper latitudes, in the higher latitudes, they are in disadvantage. So what they have done, they have devised a different kind of orbit that is called the sun synchronous orbit. So it is not geostationary orbit, but it is also having orbital period of 24 hours. But it is not in the equatorial plane. So it is not in this kind of plane. It's not in the green orbit, but it is in this white orbit. So it is highly elliptical orbit. So it goes very high up when it comes to the near to that country. And you can see that these two satellites are moving very slowly when they come to the upper part, and when they go to the lower part, they will move very fast. So they come very quickly to the same spot. So they are not as efficient as geostationary orbits, but still they serve a big part because they remain in the vicinity of their country for a very long time. You can see that the satellite has become very slow now, and when it goes down, become very fast. So that comes from the orbital laws. So as the satellite goes near to the apogee, then it moves very fast, and then goes near perigee, it moves very slow. So because of slow motion, it remains in the Russian orbit near to the Russia for a very long time. So that is the advantage, and this is a very intelligent way of choosing one orbit. Now, the second important thing is that in what channels we take the observations. So meteorological satellites mostly work in the visible spectrum, infrared spectrum, and the microwave. If you see the radio spectrum is quite large, it starts from gamma rays, then X-rays, ultraviolet, and it goes to the longer wavelengths from the radio waves. But meteorological satellites are using only visible, infrared, and microwave, and also the radio waves. And I'll tell you that how they are using the radio waves. Apart from that, they are using two types of instruments. One is the active instrument, and one is the passive instrument. Active instrument means when the satellite is using its own source of energy, like the laser, then it's called the active instrument. Radar is the active instrument because radar is sending its own pulse. But passive instrument, what is the passive instrument? Our eyes, for example. Our eyes is a passive instrument. So if we switch off the light, we are not able to see anything. So our eyes cannot work if there is no light. So we are not producing our own source of light. But some satellite can have their own source of illumination, for example, lasers and radar pulses. But some other satellites, which are passive satellites, they have to depend upon the Earth's emission or the solar radiation to make the measurements. Now, what is the advantage of visible? Actually, visible can give you very high resolution, and visible gives you the picture as we are seeing in the actual physical world. So visible is the same as we are seeing from our eyes. Then infrared, what is the advantage of infrared? Infrared is actually depending upon the heat of the objects. So it is not depending upon the sunlight. So it can work in the nighttime also. So we are able to see the clouds in the nighttime also because of the infrared channels. But visible and infrared both will give you the observation only of the top part of the cloud. They will not give you even I think 10 meters below the cloud. So it is very difficult because all the radiation is absorbed at the top level only. So we are not able to see anything below the cloud. But in the microwave can penetrate the cloud because microwaves wavelengths are quite large. So microwaves are not scattered by the clouds, but they are scattered by the rain. But we are able to see what is happening below the clouds. So microwave instruments can give you the observation even in the presence of clouds. And the third category is the radio waves or the large microwaves. So those large microwaves are basically, they are able to penetrate the rain also. So this kind of observations are very valuable when it is raining heavily, like in the tropical cyclones and in the flash floods. So these radio frequencies can penetrate even the rainfall, and they can give you the measurements to all the layers of the rainfall, even though no matter how much rainfall is taking place. So but as you go more and more higher in the microwave and the radio waves, their resolution goes poor and poor. So these pictures become more and more coarse. In the visible, pictures are very sharp. As you go to the microwave and radio waves, the pictures are becoming more and more dull and coarse. But they have their own advantage and disadvantage. And then there are active microwaves. They can give you the profiles of the rain. They can give you the rainfall structure in the three-dimensional. So that is one advantage of the microwave also. Then current generation satellites are very sophisticated. Actually, they can provide you a lot. They are fitted with the very, very sophisticated instruments. For example, they can detect, apart from visible and infrared observation of the clouds, they can detect X-rays. They can detect extreme X-rays. They can detect the ultraviolet radiation. They can detect the lightning. They can detect the magnetic field of the Earth, and so many other instruments. And they are as heavy as a truck actually. And advanced sensors like USA and Japan, they are operating this kind of state-of-the-art satellites. So nowadays we are having a number of weather stations, both in the geostationary and the polar orbits and the sun synchronous orbits. And nowadays we cannot think of any weather forecasting without the use of these satellites. And this is the constellation of operational weather satellites. So you can see that they have a Meteosat satellite for the Europe, Meteosat third generation, GOES satellite for the USA, Himawari satellites for the Japan, GeoCombSat for the Korea, FY series of satellite for China, INSAT series of satellite for India, and then we have the Electro satellite for the Russia. And then apart from that, we have the Arctica satellite that I mentioned about, that sun synchronous orbit, geosynchronous orbit. This is highly elliptical. It is operated by Russia and other countries like Canada, because they are in the upper latitude, so they get advantage of this sun geosynchronous orbit. And this is nearly a total constellation of different satellites. India had a very rich program of the weather satellites. So we launched weather satellites as early as 1980s. Then after that, we had the INSAT 3D, INSAT 2A, 2B, 2E, Kalpana, and then we are having currently INSAT 3D and 3DR. And we are having a plan to launch a JSAT satellite in 2021. So this is the plan for this year. So these kind of satellites India has a very rich heritage of weather satellites. Apart from that, they have a polar orbiting satellites also, like the OceanSat 1, OceanSat 2, Saral, Altica, Megatropics, etc. Then how big are the satellites? Actually, satellites can be as small as a 5-kilogram satellites to as large as a 2,000 or 3,000 kilogram, to the size of a truck. So nowadays, people are talking more about the small satellites because they can be launched very quickly and they can be replaced very, very easily. So nowadays is the time of small satellites that are called the CubeSats. And there are so many satellites actually in the orbit. Sometimes people ask that how many satellites are there in the orbit. So total number of satellites that have been launched so far, 11,000 satellites has been launched so far. Out of that, total satellites still which are in the orbit are 7,389, out of which 3,300 satellites are active, and Earth observation satellites are 906. And out of Earth observation, meteorological satellites are 60. So this is, I think you can see, but this picture is not as bad as this because the satellite, it is not to the scale. Satellites are very, very small. The space is very, very big area. So these satellites are nothing, but this is just a representative picture. And this market is increasing very drastically. Now it is an INSAT 3D satellite. It has a 19-channel sounder and 6-channel imager. Sounders are basically used. Sounders you can, when I tell you the channels, it's actually one channel is basically like a filter of a camera, by which you can filter and you can split one beam into a very different type of pictures, and you can take many pictures, as you can see that in the multispectral. But time is short, so I'll not go to this example. So you can see that these are the 6 pictures taken by 6 different channels of INSAT 3D. So you know that the same cloud does not look the same in all the pictures. Okay, the clouds appear very differently. For example, you can see the first picture and the second picture, some clouds appear very dark. Can you see this? Some clouds appear very dark. So these dark clouds are actually the clouds which are having large ice content, and these are the clouds which are having a lot of water content inside them. So because they are, it shows that which clouds can give you the lot of rain in the future. So apart from that, these satellites are, these kind of geostationary orbits are able to provide you a lot of information. One of them is the monitoring of the tropical cyclones. And you can constantly monitor them because you don't have to bother about whether the Earth will rotate or not, because they are the geostationary satellites. I'm sorry, actually I'm running out of time. And a lot of products like the winds are derived from these satellites. And there are the number of products which are coming from these satellites, like the rainfall, sea surface temperature, water vapor winds, OLR, upper tropospheric humidity, solar radiation, fog, aerosols, etc. Then we are having the vertical profiler instruments also, which will give you the vertical structure of the atmosphere. As I told you that we have to know what is happening to the vertical structure of the atmosphere. So nowadays satellites are equipped with the very high quality instruments which can give you the 3-dimensional picture of the atmosphere. They can tell you where in the upper air, where is the heat is more, what is the temperature is more, where the humidity is more. And this all information is extremely valuable for the models and the weather forecasting. Then there is a SCATSAT. Then nowadays we are able to know that what is the sea level. So there is a small radar which is operated from a satellite orbit, and then when radar pulse comes back, it can give you the signal about how high is the sea level and what is the structure of that sea level. So it can also tell you what is the storm surge and what is the sea surge and what is the storm level height. It is very important because it is a very big problem for the climate change, the sea melt and all these things. So this is a brief overview of what kind of observations we can take. We can take the air quality observation, wind observation, sea surface temperature, sea surface height. All these observations are available from present weather satellites. This is very dramatic observations that we get from the GPS satellites. Nowadays, no service like all the shopping that you are doing from the online shopping, you are ordering the food. It is not possible without the GPS satellites because all the vendors and all the delivery boys are using the GPS services. But this GPS service gives a very good advantage for the weather. It gives you very high quality weather observations also. So the meteorologists have used this observation for weather. So you know that these are the GPS satellites which are available at which are orbiting at the 24,000 kilometer height. Apart from that, there are several low orbiting satellites also. So when a GPS satellite sends a signal, it passes through the atmosphere and it actually does not go directly, it bends. And this bending depends upon the temperature and the humidity of the atmosphere. So it means if you can know this bending, you can also know what is the temperature and humidity of the atmosphere. And this is one of the very accurate observations of the Earth system. And another kind of new instruments is basically the GPS refractometry. The same GPS signal, this is the refraction. Actually, in this case, it is measuring the refraction, but in this case, it measures the reflection. So you can see that there is a GPS satellite. It sends a direct beam, and one beam is it falls on the ocean surface and it gets reflected. And there are 8 satellites launched under this scheme, and these 8 satellites are constantly orbiting in the low Earth orbit, plus minus 40 degrees. And sometimes they pick up these deflected signals. And these reflected signals are very valuable for measuring the very high winds, like the tropical cyclone winds. So these kind of very high quality new observations are coming in the future. And this is kind of other radar observations. So this is a short summary of what kind of observations we are getting. From infrared and visible, we are getting clouds, atmospheric winds, atmospheric temperature, atmospheric humidity, aerosol, rainfall. From active sensor, we are getting cloud profiles, in the wind profiles, aerosol profiles. In the microwave, we are getting rainfall, temperature, all these parameters, soil moisture, sea ice, snow, etc. And soil moisture, etc. So many other instruments we are getting. And nowadays, we are having a lot of constellation of these satellites, which are together. They are providing a lot of other instruments and very high quality observations, which are not available till now. For example, in the second picture, I showed you that this is called the ADM, Atmospheric Dynamic Mission. This has a very powerful laser, not powerful, a very efficient laser, and it measures the winds, and it has been launched very recently. I think this is the end of my talk, and thank you.